Good morning, everyone. Welcome to East Point IKYA event. It is an intercollege technical event. So, IKYA 2020, it is organized at East Point College of Engineering and Technology in association with IEEE Students Branch, East Point IEEE Students Branch, Bangalore Section. Now, I would like to I request Anusha to take over the event.
Thank you so much, Mom. A very good morning to everyone, and welcome to the most exciting and awaited celebration of IKEA 2020. Myself, Anusha, from 5th SEM, Department of EC, EPCET. I am so pleased to have the opportunity to welcome you all on behalf of East Point IEEE Student Branch, East Point College of Engineering and Technology, to the inauguration event of IKEA 2020, Innovators Together. This event is graced in collaboration with IEEE Bangalore branch, and a special thanks to the chairperson, Shri Punit Kumar Mishra sir. We have an amazing event planned for today and are excited to share this time with you. When innovation descends into the heart, if there is darkness within, it illuminates it. And if there is already light, it intensifies it. Now, I request Ms. Neeraja for the invocation song. Over to you, Neeraja.
Yeah, she will be coming. Just a second. गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणाधीशाय गुणातीताय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय धीमहि गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि. Thank you.
Thank you, Neeraja. It was a good one. A ray of light is a ray of hope. Let's all leave the darkness behind and step towards the bright path. Now, I request our dignitaries, our beloved principal, Dr. E.S. Prakash sir, guest of honor and chief guest for the day, Mr. Ashok Narayan sir, and our HOD, Dr. G.S. Yogesh sir, for the virtual lighting of lamp.
Inaugurated.
Over to you, Vedavati ma'am and Yogesh sir.
Anusha, please welcome the guest, principal sir and other dignitaries.
Yes. I would firstly a sincere tribute to our founder chairman, Dr. S. M. Venkatapati sir. I owe much gratitude to welcome our respected chairperson, Srimati Ramadevi madam, and respected CEOs, Sri Pramod Gowda and Sri Rajiv Gowda sir of East Point Group of Institutions in their absentia. I now would like to extend a special welcome to our beloved principal, Dr. S. Prakash sir, EPCET. I take a great pleasure to invite our chief guest for the day, Mr. Ashok Narayanan Potti sir, for the event. We welcome you, sir.
Thank you.
I would like to give a warm welcome to our beloved EPISP Council, Dr. Yogi sir, HOD of EPCET.
Thank you.
I would now like to welcome all the HODs of various departments and all the faculty members of EPCET. We welcome you all. Not forgetting, I welcome the students of various colleges who took great effort and showed up today on this occasion. I also welcome all my friends who had made their presence. I welcome you all. I now request for the inauguration of IKEA 2K20. Over to you, Vedavati ma'am and Yogesh sir.
Yeah, I'm sharing my screen. Screen is visible.
Vedavati madam, you can proceed. It's visible.
Okay.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Thank you, ma'am. Thank you, sir. A lighted lamp doesn't speak. It introduces itself through its light. Its achievers never express themselves, but their achievements expresses. Now, I request our beloved HOD sir, Dr. Yogesh, to give a small introduction to the gathering. Over to you, Yogesh sir.
Very good morning, everyone. It's my very good morning, everyone. It's my privilege and honor to speak on this occasion. East Point IEEE student branch has engraved in its essence this IKEA 2020. We have three takeaways in this technical fest of IKEA. The first one is exposure, second one is competency, and third one is diversity. Dear students, technical fest like IKEA gives a lot of exposure to your idea. The idea you have in your mind is of not much use until it is shared with smarter and optimistic people who are willing to work for your idea, and you meet such people at this technical fest. So IKEA is one platform which will give you an opportunity to do this. So the second one is competency. See, dear students, test your competency, and anything that tests your competency make your future more competent. Do remember always. And the third one is diversity. The best part about our technical fest IKEA 2020 is that it gives you an opportunity to meet various people. It's where different people of similar interest meet together and share their ideas. With these three takeaways, definitely it will help you to get knowledge in the technical field. The technical field which we go through in our engineering life needs a practical knowledge. In this regard, this technical fest helps a lot. I heartily welcome all of you to this technical fest IKEA 2020. It's my great privilege, to have a chief guest like Ashok sir. He is the legendary personality in Dell systems in his own field of area of interest, that is embedded systems and machine learning. We artfully welcome you, sir, Ashok sir.
Thank you, sir.
Yeah. With these few words, I heartily welcome all the participants throughout India for this technical fest. Thank you very much. Over to Anisha. Ashok sir, you can start your session. Yeah.
Sure.
Yeah.
Software engineer for IBRAC and CRI firmware development at Dell EMC's Bangalore Development Center. He is having over 2 decades of software development experience in both management and technical leadership roles. He is also passionate, hands-on engineer with strong expertise in bootloaders, Linux kernel, device drivers, Yocto, machine learning, and artificial intelligence. He holds MBA in Masters and Masters in Engineering from Vitspilani. I now hand over the session to the guest of honor and keynote speaker for the day to take over the session. Over to you, Mr. Ashok, sir.
Yeah. Good morning, everyone. Am I audible? Sir, am I audible?
Yes, sir, please.
Yeah. Good morning, everyone, and I'm extremely happy to to be part of IKEA 2020 Innovators Together session, and happy to share my thoughts in my experience and to the young graduates of East Point College of Engineering and Technology and other engineering colleges around this Bangalore. So I have two agenda today. The first one is keynote speaker, and where I want to share my thoughts about how we move along with the world, the changing world. And the second one is a technical talk about TinyML, which is a new field of creating or developing intelligent embedded devices. So let us move on to the first point. So this is one of the key message I want to take away for today's session. That is, observation for opportunities and the learning keeps us relevant and enjoy our time. So most of most of the people in my age group have seen how the technology changes over a period of time, and it is very important for us to keep the changing technologies and change ourselves, to keep us relevant. So there are two parts. One, for the first part of this session is this theme is observing for the opportunities, and the second one is the learning. Right. So I want to give some examples of how the observation for opportunities helps us to align ourselves with the industry. Right. So we are in the fourth generation of industrial revolutions today, and in 1780s it was called first generation, where the mechanization and steam power and weaving industry took place. And in 1870s, the mass productions of and electrical energy invention happens. And 1970s, the industrial automations and electronics boom has started. Now today we are in fourth generation, where digitization, security, IoT, network, and AIML leading the road. So now, if you see in the first three generations, there were about 100 years, between two major revolutions, but that gap is now start reducing. We after 1970s, we are now calling ourselves as fourth generation in 2020, and so that means the technology is moving really fast, and we have to keep ourselves in this journey. So when is going to happen? Fifth generation? Yeah, we don't know, but let us hope that it is restores our planet. So the second part is learning, right? So there are, as we see in the previous, every generation has created a lot of opportunities. Some of them are very disruptive technologies, and some of them are changing the way we live in this world, right? So these innovations and opportunities happens in all domains, whether it is medical, manufacturing, education, or governance. So in today's talk, we are going to focus a little bit on AI and ML, machine learning and artificial intelligence, and how it is going to be disruptive in future, right? And specifically, we are going to talk more about the IoT and edge devices and ecosystems around that. So if you see right here, recent years, the ecosystem are actually giving the opportunity to create intelligent devices, and the devices like Cortex-M, Raspberry Pi, Arduino boards, the network evolutions, like we are in 4G right now, and it's going to happen 5G shortly, right? And in the technology, right, AI and ML. So all these technologies are helping us to create more intelligent devices around us. Right? So in today's topic, we are going to see how we can part of this new revolution of edge and IoT device computing, right? It is not just edge computing. Edge computing was there since very long time, but now we are talking about intelligent edge devices, right? So that's where we are more focused on today's session. So the opportunities in this edge and IoT devices are many, actually. So there are opportunities in hardware, platform, and services, but more than that, the applications of this is what going to see everyone in their life, day-to-day life, right? The smart cities, the Internet of Things, the automation, remote monitoring, content delivery, AR and VR, augmented reality and virtual reality, right? And autonomous vehicles and drones and gaming. So these are the few areas, right? The most of the applications are evolving. And I have taken this from one of the market research, which is published in the bottom of the screen. So if you can go and read that paper, right, there are a lot of research content published in that paper. What are the opportunities and the market on this IoT and edge devices. So in this talk, first we saw the identifying the opportunities, and then we saw what we need to learn, right? So now we have to see this slide, right? So this gives us a little bit more details about the market that we are talking about. And right now it is about 3.6 billion market, and it's going to be 15.7. That is the estimation for 2025. So it is huge, right? And And as we we are going to get advantage based on how we equip to take over this new domain with respect to skills. So again, I just want to reiterate the main point I want to convey in today's keynote is the observation for opportunities. Learning keeps us relevant and enjoy our time. So with this, I thank you for this keynote session opportunity, and over to you, Anisha. Anisha. Okay. Good morning, everyone. So this is a technical session. So as Anusha introduced, my name is Ashok. I work for Dell EMC and Bangalore Development Center. So I have over 2 decades of experience in firmware development domain, and for past few years I have been working on AI and ML domain also. And today I'm going to talk about an interesting field called TinyML. I'm sure how many of you aware of this TinyML. It is called Tiny Machine Learning. So this is basically a machine learning for embedded and edge or micro devices using TensorFlow. So the TinyML is a process and technology used to create machine learning for edge and IoT devices. Right? So we are going to talk more details about it's kind of very packed sessions. So during these sessions you may have questions. I request the questions, if you have a chat facility, you can type in your questions there, and probably at the end of the sessions maybe Anusha or one of the uh, panelists can filter, and then we can address those questions at the end of the sessions. And you can also see my LinkedIn and email addresses. Please feel free to connect with me on LinkedIn, and for any questions after the sessions. So let's begin this TinyML for machine learning and edge and micro devices. Okay. So if you see the machine learning tools landscape, right, it is very huge, and the TensorFlow, PyTorch, scikit-learn, and these are some of the main technology we hear when we look into the technology or the tools or infrastructure side of the AI and ML. But today's sessions, we are very focused on a very specific area. So it is based on a TinyML domain, but the TinyML, though it's a concept, the TensorFlow framework has supporting the TinyML possibilities, right? So we are going to talk about a little bit about the machine learning and TensorFlow. So in these sessions, I'm assuming the students have reasonably good or introductory level of knowledge on machine learning and TensorFlow. But though if there are new students who want to learn these things, I have a very small workflow where one can take those 2 slides as kickstart to learn this new domain, and then we'll get into what is TinyML and what is edge device, what are the edge devices, and then we also get into specifically how TensorFlow enabling the TinyML possibilities, right? Then at the end of the sessions, we have I have given some references and readings, and this TinyML is something very new. Google has released it on 2018, the very first release, and since then, there are a lot of features are being added in TinyML, specifically TensorFlow Lite and TensorFlow Lite Micro. So let's get into the main content of this. So this is for those who are going to start the machine learning and TensorFlow. So this is a very quick introduction to what is machine learning, right? So what is difference between the procedural programming and machine learning? So in the left side, right, we see the procedural programming, and if you see here, let me take if you see the left side, the line number 7 is something rule, right? It's the equation of a straight line, y equal to mx plus c. So here the m is the slope and c is the y-intercept, right? So if we know this m and c, we can write a procedural programming to find the value of y at any given x. So now if we connect all these dots together, we get a straight line. So we know the equation here, right? We know the formula here, that is y is equal to mx plus c, and we can generate the value of y for any given values of x. And if we plot it now, we just see the straight line, because that is the equation of the straight line, right? So that is procedural programming. So here the rules we are writing our favorite language, whether it is C or C++ or Java, we are using those languages to create the rule in as a function, right? And the input to that is the values of x, and the output of that blocks is function is the value of y. So this is something procedure programming. Then now, how is it different from how the machine learning is different from this procedure programming? So in machine learning, we only get the observations. Now we get the values of x and we get the values of y, but we don't know what is the underlying functions which generated these values. So on the right side, I have the values of x and values of y, but if you see, it looks like a linear relationship, but it is not exactly a straight line, right? But so here the task here is to find the function which generates these data points. So if you see in the right side top, the block diagram, so that is something very high level, how this function is calculated, right? How we find this function which generated these data points. So here again we are assuming the function is linear, that is f of x equal to mx plus c, and so that is called choosing an hypothesis, right? So we are assuming that okay, these data points are generated from this hypothesis of straight line, and so we then calculate we initially start with the random values of m and c. Here the parameters are the slope and intercept. So we start with the random values of m and c, and then we have defined a loss function which computes how far the calculated value differs from the true value, right? And once we calculate the loss, then we go and adjust the values of m and c. So that's the feedback loop you see from the output to the input of f of x function. So this is an iterative process, and at the end of this, the objective here is to minimize the loss function value, right? So once we get a minimum loss, then we usually find the best fit line which satisfies this relation between input and output of these data points. So that is in brief about machine learning. So I have only 2 pages for machine learning explanation. So this is first one is very high level, and second one we just go into detail about here. So as we see, right, the observed values we see, it is not really a straight line. We see the observed values have randomness, it will have measurement errors. We may not record all the parameters related to the system, right? And then the values also differs based on the operating environment. So because of all these things, right, so using a machine learning or linear equation method, right? So we cannot take any 2 points and then generalize that function for the entire data set here. So the machine learning, as we discussed in the previous slide, we define a loss function, and if you see the loss function on the right hand side, let me take a pointer just a second. So here this is loss function, right? So this is a graph of loss functions, and if you see, we find the best value for the parameters. The parameter here is the slope m and intercept c. So we find the best value where it minimizes the loss. So this is a graph of the parameters on the x-axis and the cost or the loss function on the y-axis, and we see we plot the loss functions versus parameters, and we pick the values which gives us the minimal loss. And that is what this machine learning, in a very short introduction, this is what basically the machine learning is. So we're basically going to find the model coefficient which gives us minimum loss for the given hypothesis, right? So if you see here, if you see the loss function is one of the loss function is MSE. MSE stands for mean square error, right? We take a difference of observed values with the true value, then we take square of it and then take the square root of it. So this basically gives us to immune from any negative observations, cancelling with the positive errors, and then we take the square root to bring it back to the same unit. So let's go to the next slide. So this is a quick introduction for the TensorFlow. So TensorFlow is one of the deep learning platform which is more popular. The other platforms I can see as PyTorch and CNTK, and but the TensorFlow is becoming more and more popularized now. And the second one, I believe it is PyTorch from Facebook, right? And the TensorFlow is an end-to-end open source platform for machine learning, and it has a very comprehensive, flexible ecosystem and tools and libraries for and community support. The community support is very important in this, and one of the main advantage of the AI and ML is most of the tools and the libraries are open source here, right? So these tools and softwares are written by the community, who are very active in contributing their features into the open source community, which people like us make use of um, to develop our products, right? So the TensorFlow, in effect, it enables developers easily build and deploy machine learning powered applications. So in the previous slide, right, we saw a linear equation which is y equal to mx plus c. So now, there are many ways to solve the linear equations. There are many libraries available in deep learning and machine learning. Scikit-learn is one of them, and the TensorFlow deep learning is another one, and PyTorch. So here in this example, this is a quick introduction of what is TensorFlow and what is deep learning. So this is something which basically finds the relation between the input and output for the linear equations, and using the deep learning for finding a linear equation is like taking a bazooka for solving a linear equation. So it is not in proportion. I'm just explaining this how the various components or various the functions involved in the deep learning. So the very first line is importing the TensorFlow library. So this program is written in Python. So I hope Python is one of the leading language for machine learning. The TensorFlow by default supports Python, and they only guarantee most of the functions so in Python. So TensorFlow supports many different other languages, but the features very first comes on Python language. Okay, so it is, and Python has become more and more popular because of the TensorFlow support as well, right? And if you see, we are taking a model, so we are just in TensorFlow we are using the Keras module, right? Keras is an API, high-level API. So if you see the TensorFlow, it is a lower level API. The Keras is giving higher level APIs. And in this example, I'm using the Keras API to create a model with only one neuron here. So this is what, here is what the one neuron here, right? So this one neuron network. And then I'm compiling this neural network with optimizer. This Adam optimizer here. So this is basically the function which does the gradient descent. Basically, it gets the loss from the mean square error loss, and then it adjusts the coefficients. The coefficients here are the m and c, right? It basically does a slight adjustment to see which direction it has to move, whether it has to increase or it has to decrease, based on the slope of the derivative, right? And so using this, it adjusts the parameters and then finds the loss which has minimum with respect to that coefficients. So if you see the fifth line, this is what the training happens. We give these examples, right? We give the x values and we give the y values, and we run 200 times. We want to run this iteration. This is iterative process, right? Every iteration it calculates the loss, then finds the gradient, and then again updates the parameters, again does the same thing again and again. So the right hand side is a pictorial representation of this graph. So I have one neuron here, and the neuron basically contains of the sigma function and the activation function. And if you see, the xi is the input, and the m is a slope associated with that particular coefficient, and we have this intercept c as the bias, and we are getting the output. So this basically represents this linear equation, this neuron, right? This graph represents this y equal to mx plus c function. And in the epoch output, you can see this is already gone through 171 epoch. Epoch means iteration, right? So it it sets one value for M and C, then it finds a loss, and then adjusts the M and C, again finds another loss. So it keep on reducing the loss, right? So like that, it has this. When I took the screenshot, it has run 171 times out of 200 which I gave, and we already see the loss is very, very small, right? Very, very small. And if you see in the second screenshot here, the true function which generated those data point for our information is y is equal to mx, that is 2x plus 5. So if you see, those data points are generated from the 2x plus 5, and this model has already learned for the slope. You can see that 2.027 as value for m and 5.0014 as value for the intercept. So this is how we can interpret the coefficients to the hypothesis we have assumed, right? So it has found the function which generated this observed values of input and output, right? So this is in brief what is a neural network, and it's very highly unlikely that one will use this deep or TensorFlow for solving a linear equations, but this is the example I have given here to explain the different components. The components here are the model itself, then the loss function, the mean square error, and the optimizer which does the gradient descent called atom optimizer here, and the matrix, how we evaluate whether the model is learning or not. So there is a matrix here, mean, absolute error, right? Now if you see this Adam, MSE or MA, these are some of the there are many similar optimizers like Adam, SGD, and there are different other loss functions, MSC, and there are different other. So based on the type of applications, right? So this program, you can see it as a regression. It is finding the continuous value, the output. The output here is continuous, right? So that is those kind of problems are called regression problems. It is finding the continuous output for the given input values. And so when you see this regression, usually we have this one neuron at the output, right? If you are predicting only one regression, we have this particular neuron is giving you this output value, right? So this example is just given to identify the different components involved in a neural network, very simple neural network.
Playing from W10 JWBF PV2.
Sorry. Okay. So, and the bottom right hand side bottom, we can see the predicted value is called y, the y fit, and the true value, right? So we can see the difference is very, very small in this case. Okay. Now here is another example, right? So how is it different? The objective of this session is on the TinyML TensorFlow for machine learning. So far we haven't talked about machine learning for embedded or IoT devices using TinyML. So how is it different? So the difference comes in not in the training process. The difference comes in when how you convert this model to the form factor which will fit into IoT devices. So here again, I am giving another example of a favorite, the MNIST handwritten digit classification. So here the problem statement is classification. The previous one was regression. Here the problem statement is classification. So that this data set contains around 50,000 digits which are handwritten. So the task here is to identify the digit, right? So that's why you see in the output there are 10 neurons. If you see the line number 19, there are 10 neurons at the output, and each neuron will tell us what is the number in the given input image. So here the input is test images. So the image contains the handwritten digits, and the output is the number which identifies what is the digit in that image. So here again, this is one of the convolutional network. So you can think of the previous example. The dense was the neuron we used. So that's the smallest unit of a neural network. So for image processing, we use convolutional 2D, and the dense at the output. Now for text classification or text processing or NLP or natural language processing, you have a different block called recurrent neural network, right? The text are sequential, right? So the previous word, the next word comes depending on the previous word, right? So it is not independent. The sequences are making some meaning, right? So the text words are, or the text tokens are dependent. So that's the reason we have a different type of network called recurrent neural network. But here in this example, we are using an image for classification, specifically the MNIST dataset. And this dataset, you see, as you see, I am just importing it from the TensorFlow Keras dataset itself. So they have given us a lot of dataset for education purpose. We can make use of this tool here. So the line number 13 to 20, we basically creating the network. So it contains the input layer. Then we are converting to the reshape. So the convolution layers also requires the third dimension here. So that is basically channel, and then we are passing it through the convolution, and then max pooling. Max pooling is basically finding the maximum value within that filter value, right? And then we are finally going in, passing it through the tensor layer to get the output of identifying. So in this case, I am using a different activation function called ReLU. So this is the graph of ReLU function. So there are many different activation functions available once you take up a neural or machine learning course. You can see softmax, sigmoid, ReLU, leaky ReLU, and these are the things, different depending on the applications. You can use different activation functions. So this basically captures the non-linear relationship between the inputs and outputs. Okay, so now coming back to, so how we save this, right? The Keras or TensorFlow provides the APIs for saving the model. So what do we need to save? Because once we train, right? Once we call this fit function, it basically trains the model to find the optimum parameters, right? And if you don't save it again, you have to train, right? The training network is very compute intensive, so we don't want to do it again and again, right? So we want to save our model so that it can be used or used or deployed in a later point of time. So once we complete the training, we have to save the model. It's important to save the model, which contains all the learned parameters, right? And so the API is provided by Keras or TensorFlow is saved model.save, and we provide the model name, the model object, right? So here is a model object which we created in the line number 13. This is the model object which we created, and that is the model we are going to save it to this folder, right? And just to get an idea what is the size of this saved model, it's about 95K, right? About 94K size is what this model size is right now. So this is actually generating classifying handwritten images into the corresponding digit, right? So that model takes about 94K size, right? Yeah, so we can see this saved model.pb is called protobuf format. It basically contains the graph. TensorFlow is basically a graph, right? It is basically creating a graph of computation and then passing the tensors along the graph to find the values, right? So and this saved model.pb protobuf is the extension pb, contains the graph and weights of this model, right? So just to remember from this slide, we are using the model.save function to save the model, and it takes about 94K of size, right? So let's go to next page. So this slide basically explaining how we can make use of the saved model. So here again, I'm using another TensorFlow API called load, and we are passing the location where we saved the model, and then we are using the predict API, right? So we are using the here we are using the loader model. I'm passing one of the test images to get the output, and we can also visualize the output is correct, right? So this is just to explain how we can make use of the saved model. And in TensorFlow, the right hand side, right? So there are a lot of language support available for TensorFlow to deploy this model: Python, JavaScript, C, C++, and it goes on like that. So the point here I want to make is here when we use just TensorFlow, we see a lot of libraries, language support available. When we go to TinyML, this scope getting reducing. So I just want to focus on that area to explain what options are available today for TinyML models. Okay, so when you develop a plain TensorFlow, yes, you have a lot of support, but when you get into this embedded devices, this is something we have to keep an eye, where things are getting reduced, scope is getting reduced here. Okay. So far what we have seen is we have to decide a problem to solve. So in the previous example, our problem set is to classify handwritten digits to one of the digits, right? So that's the problem area. And the collecting required data set. Yes, we used the data set from the Keras. We did not go and collect all the data set, but this is one of the major tasks for any machine learning based projects. We have to collect our data set. And then we also see, we designed a model, right? We designed a model with the input, and we designed that model had convolution layers, and then finally we had the output dense layers, right? So that's how we designed the model. Then we trained the model, then we ran the inference to get to the prediction, and then we did an evaluation, troubleshoot, and deploying the model with different language supporters, right? So this is what we have seen so far. But how is it different for TinyML, right? So here is some, I have already used some of these terms, but there is something to understand here is this jargons, right? So there are three things. One is TinyML is consisting of TensorFlow Lite and TensorFlow Lite Micro for different form factors. So we see what is this, how these are different for these two TensorFlow Lite and TensorFlow Lite Micro stuff. Okay, so we have already seen what is TensorFlow. Now, sorry. So the TensorFlow Lite and TensorFlow Lite Micro is what something we use when we do an embedded IoT or micro device machine learning. So in general, TinyML is an emerging field of study that explores the type of models that you can run on a small low power devices, such as microcontrollers. And the framework from Google, which is TensorFlow Lite and TensorFlow Lite Micro, is what enables us to do or to develop such machine learning models for these small embedded device controllers. So we will see both of these in shortly. Let me go to the next. So in this slide, I just want to give you an overview of what is TensorFlow, what is TinyML, and how TinyML Lite and how TensorFlow Lite and TensorFlow Lite Micro related to TinyML. So these are some of the devices, right, which we can which TinyML is focused to run on. All these are very low power, very low cost devices where we can use to deploy edge or IoT applications, intelligent applications. For example, you can have one of this machine learning intelligent application developed for your washing machine, or to control your light, or to control your fan. Or if you want, you can create one such a very small application to unlock your main door, like using fingerprint. For such small applications, right? So these are the devices available. So like SparkFun, ARM, and HiMax. So all these are already supported by TinyML. Right? So here are some few points I just want to make sure. How is it different from the compute at the edge and the constraints? The computing at the edge, right? The advantage, if you capture, there is no latency. The data never leaves the device, and it's also many companies have the security concern also, right? We don't want our data to send to some cloud and get back the inference from the cloud. So we don't know how those data is getting used later point of time. So when we develop an embedded intelligent application using machine learning, the inference happens on the device itself. So all the readings which collected by the device, which could be our personal device, personal informations like fingerprint, right? Fingerprint, or your voice, right? So those data never leaves the device, right? And the security is something which many people have very concerned about in developing machine learning. So because our voice and our fingerprint are all getting transferred to the cloud, and later we don't have any control about those data. So so that's one of the advantage here. So when we develop an intelligent application, intelligent controller, and with machine learning algorithms inside, the inference happens on the device, so that the data never leaves the device. Then latency, there is no round trip delay, to the cloud and then back to the device to get the response. So there is no, the latency is minimum, or it's not there, or the privacy, right? There is, we already spoke about privacy. The connectivity and the internet connection is not required because the intelligence is inside the device itself, and it is less power consumption. Because mainly it is because there is no network connectivity. Network consumes a lot of power. Because there is no network connectivity, these devices are also very less power hungry. But there are constraints also, right? The machine learning model has run within a very small battery operated devices. The power is the main concern there. The size of the binary, right? Usually the machine learning, usually this embedded devices or microcontroller devices doesn't have much memory. So the model has to fit within that small binary size, right? The memory, how much RAM is required to run the model. So these are the areas that TinyML as the infrastructure going to solve for us, right? And if you see, the handwritten digit classification took about 94K, and that is huge for these devices, right? Very small devices, it's huge. So we are going to see how the TensorFlow Lite and TensorFlow Lite Micro going to enable us to develop such a small applications for these low power devices. So the TensorFlow Lite is a shared library or static library we can create, and typically it is used on on the mobile phones and those kind of form factors. But the TensorFlow Lite Micro is for the very small low power battery operated devices, and so that's the difference between these two libraries. Okay. So now the summary, the TinyML workflow, how is it different from the previous workflow we saw? So there are the main steps I have highlighted here. So we are now going to convert the model to a .tf Lite format, and then the run the inference, right? So other steps are same here. Other steps are same as what we did in the main TensorFlow. Now in TensorFlow Lite, we are going to make some changes to the step number 5 and step number 6 here. Okay, let us get into more details about that. So the TensorFlow Lite converter, the step number 5, is basically converting the models to an efficient form to use by the interpreter. So the interpreter here is something which runs the model on the embedded device. So we see how is it different from hosting the model on cloud. So here we have another module called interpreter. That is the one going to run the TF Lite model, the converted TF Lite model, TensorFlow Lite models on the device. So these are the two steps which is different from the conventional machine learning development model. Okay, and these two steps enables us to. So if you see already, if you are already familiar with the TensorFlow or machine learning, most of the steps are same, except we are making a small changes in the step number 5 and step number 6 to develop application for the machine learning or for the embedded devices, right? And yeah, so the step number 5 was related to saving the model, right? To save the model in a form which is good for the embedded or micro devices, right? So the TensorFlow Lite provides 3 APIs for that purpose. So we can convert directly the Keras model itself. We have in the previous example, we have seen that we are using Keras model to save the model to a folder, right? We have seen, and then the saved model. Once you save the model, then we can read it back and then convert it into TF Lite. And then the last one is the concrete functions, which basically a function which stores the graph and the weights associated with that. So we basically give a function in the conversion process and along with a data set which will learn the critical path without reducing the accuracy of the model output. So that is the last option, concrete function option. So there are 3 methods available for converting your TensorFlow models to a TensorFlow Lite model, right? And that is Keras model, saved model, and concrete functions. So we are going to see how what changes it makes, these APIs makes to the model itself. Okay, so this slide right now you don't have to read this. This is basically what exactly these APIs are doing, right? The quantization is basically reducing the precision of the weight and parameters. Right? Instead of 64-bit, now converting to 32-bit so that you get size reductions. Then pruning here is cutting down the branch which doesn't make more sense for the inference path, right? So basically, if you have in a tree, if you have a branch which doesn't give you a lot of fruits or flowers, so basically what you do is, okay, maybe it is infected and it's not useful. So we basically prune so that the other branches get more. So here basically we are seeing the branch which doesn't contribute to the inference. We are basically pruning it. So that basically reduces the size of the binary. And then the clustering. So this is something I can give an example of the grade. For example, the A grade, B grade, and C grade in the exams, right? So basically we group a set range of marks to a particular grade, right? So similarly here the coefficients which are in a range of coefficients are taken maybe an average or median, and then we assign those values to those nodes. So here advantage is it's basically compressing the values the network has to store, because here we are now grouping a bunch of values to one single number, so we don't have to store the various values. So that is the reason this clustering comes in effect. So this is in brief how this conversion, how we are saving the size of the model. Okay, so basically the quantization, pruning, and clustering. Okay. So now here the TensorFlow Lite converter, right? So we have seen in the previously the model size was the just model was around 94K, but together with other parameters it was 356. So now we are able to reduce it to 84K. How we are able to reduce 84K? If you see the example is same example. It is the handwritten digit classification example, but the right hand side, we are using a TF Lite converter API and from Keras model API. So out of the three, we are using from Keras model here, and we are passing the model object to it, and then we are calling the converter.convert function. And now if you see the size of this model, which has gone through this quantization, pruning, and clustering, right? So it is giving us 84K size, from 356K size is giving us 84K size. Now, if we enable the optimization of that, then we see that size of the model is further reduced to 23K. So think, this is a very complex handwritten digit classification problem, and we are able to reduce the size of the model to 23K size, right? But we haven't used, we just used only the default optimizer options, but there are many few more optimizer options available in the TensorFlow reference. You can go through that. So those things also, basically now we are using 32-bit, right? So some applications don't require 32-bit precisions. We can even further go down to 8-bit input and output options, and so that will further reduce the size of the model. So so this is how this conversion happens here. Now, so now we have gone through the step number 5, that is converting a TensorFlow model to a TensorFlow Lite model, which reduces the size of our trained model. Okay. Now let's go to next page. Now, how do we interpret here? So we have the interpreter API. So if you see the line number 3 in the left-hand side, I have highlighted here. So it's a tf.lite or interpreter, where we load the saved model, TF Lite model, and then here is what slight difference is. Here we have to do a little more extra steps, right? We have to allocate tensors ourselves. We have to get the input tensors. We have to get the output tensors from the interpreter, and then we have to pass the input parameters through the input tensors. And then finally, we are calling the interpreter.invoke function to get the inference from this. So this is where the slight difference, where you see from TensorFlow Lite to TensorFlow Lite interpreter models, right? And this is an example of how do you infer the new data using this model on the embedded devices. And the SDK or API provided here are for Android, iOS, or ARM64 or Raspberry Pi kind of devices. As we saw discussed earlier, TensorFlow is for cloud and heavy compute heavy deployment purposes. TensorFlow Lite is for mobile phones and those kind of embedded devices. Now we are going to see next slide. We are going to see how TensorFlow Lite Micro for the small form factor devices. Yeah, so in this TensorFlow Lite, we can create the static library like lib TensorFlow Lite.v, which is a static library, and then we can also create shared library. So these libraries are created so that you can link these to your C or C++ modules, and or you can directly use a TF Lite interpreter to run a Python on the embedded devices. So multiple options are available in this case. Now this slide just to give some, we don't have to train for every use cases. So usually the TensorFlow hub gives you a lot of trained models for us to use, and there is a concept called transfer learning. The transfer learning, basically what it does is you basically import a trained model, use those weights as it is, and you add a couple of extra layers at the output side, so that those layers will be trained on your or limited new data. So this concept is called transfer learning. So basically, the pre-trained model will identify all those the patterns of your problem area, and then the customization happens at the output, the new layers which you added here. So it is recommended you first, when you are starting a project, first go through the TensorFlow hub and observe or just to review whether a similar applications are already available or models are already hosted on the TensorFlow hub. If it's available, use the transfer learning methodology to develop your applications in a faster way. Otherwise, you need a lot of data for training, and a lot of compute also required for the training purpose. So here, if you adopt transfer learning, you don't need too much data and you don't need too much compute fare for training also. So your development cycles will be very faster. Okay, now let's go to what is TensorFlow Lite Micro. So this is for microcontrollers, right? So yeah, the step now. So here again, the step number 5 and 6 are having some changes, and in step number 5, there are few more steps involved in this case. So see, here we are talking about running a machine learning model on a very, very small battery operated devices, right? It may have an operating systems like Linux or ThreadX or any R2S, but it may not have any operating. It may be just a bare metal device. Bare metal means you simply run your model in a while one loop which keeps reading the input and gives some output, right? So it may be just a binary which runs on that. No, there is no operating system support. So this TensorFlow Lite Micro, right? It supports both these use cases, and the changes here is integrating this TensorFlow Lite Micro libraries to your SDK. The SDK here is, there are various SDKs, right? So for if you are doing an Cortex-M development, you may get an SDK along with that board. Or if you are working on a different embedded projects, Yocto project is another SDK, and so there are various SDK, distributed along with the microcontroller you choose, right? So the first task here is to integrate the TensorFlow Lite Micro libraries into the SDK. Then the next two step is which makes the micro step little different from the previous one. So we have to first convert the TensorFlow Lite model into a hex array. Now our model is in a hex array now, and then that hex array, here hex array means just you think it like a C array, right? So that's exactly this hex array means here. So and then you integrate that hex array into your workspace, then build the model here. So let us see the example of that part here. Okay. So we need C++ 11 standard for this. So in the right hand side, the input here is TensorFlow, the model.tf Lite, which is the same model which we have converted in the previous slides, right? And you pass it through an hex converter. So XSD is one of the hex converter. You can write your own hex converter also. There are a lot of examples available in the internet for that purpose. So it is just a hex array which converts this model and then creates an hex array. And the right hand side is how this hex array looks like. So here the model array contains a bunch of numbers. Those numbers are representing the .tf Lite model. Now this model.cc file, cc file is the C++ extension, so that you integrate in your SDK. Here SDK is any depending on the board, right? So depending on the board, you can have your own SDK. So I just showing how this model.cc is part of your source tree, and I also highlighted the main function .cc file. By the way, all these examples also available in TensorFlow Lite GitHub. I will give a reference to this at the end, right? And the examples here contains how we build this model and invoke this model to pass the input parameters and get the output. So the next slide we will see that part. Okay. So here the main thing is we have covered the step number 5. The step number 5 is converting the model.tf Lite to an hex array, and this hex array is now integrated into your embedded workspace. So we just copied that model.cc into your project workspace, where you are writing an embedded TinyML based application, which contains Makefiles or any build tool, right? So you are just including your model.cc into your Makefile there. That's all you have done so far. Let us see how to make use of this model.cc in the next one. So so don't get confused with so much C code here. I'm just going to highlight what is really required to focus at this point of time. So yeah, the very first few lines are a bunch of header files, right? Header files gives us the API definition of TensorFlow Lite micro libraries, right? And then we are going to load the model. See, if you see here, the right hand side, the model equal to TF Lite get model, and we are now reading the models, right? So this is where we are now loading the model into the C++ file. And once you load this file, right, we also define here, if you see the model input and output. Yeah, so these two lines, the bottom of this page, we are now getting once we load the model, right, we are getting the interpreter, the instance of the model. So from there we are getting this model input and the model's output into your local variable, input and output variable, and we are going to use these variables to pass the input values and then get the output values. So we are in this page. The main thing to focus here is the get model function API given by TF Lite class, right? So get model, we are loading the model, and then we are now getting the input and output tensors of this model, right? And let's go to the next page. Now we will see how we invoking this model also. Let me see where it's invoking. So this line number here, I'm just passing some value to the input tensor, right? This example, it could be whatever, your sensor readings or whatever it is, you are passing to the input sensors. Then you are now invoking the model using interpreter.invoke function. So this is where the machine learning model is given with your new data. And once this function is invoked, the output tensor, you are going to get the output corresponding to this model, this invocation of data set. And that one you can make use of it. Suppose you are if your input data is for a speech recognition, we, for example, this we use Hey Google or Siri or Alexa, any of those things, right? So those use cases, there will be a small microcontroller based TinyML model, right? TinyML running on the microcontroller, which will be active or which will be on always to listen to the voice, right? And whenever it sees this pattern, it wakes up the main processor, right? So now this input tensor is your speech streams, and then the output tensor is whether is it Siri or is it Hey Google or is it Alexa, and based on this, the further processing happens. So now your TF Lite model basically recognizes this speech. TF Lite model basically recognizes speech, and it identifies the command to wake up, right, based on this. And then you are invoking the main processor, which does a lot of processing. So this is the main step in TensorFlow Lite Micro, and because it is micro, one more step which we have to do is right now, we have to specify how much memory, how much memory required by this model here, right? So this is right now, it is kind of trial and error. Now you have to first see how much memory required by this model. So based on this, you have to adjust the size of memory requirement. So that's what this K model arena size here indicates. So you have to find what is the best value for this one, and then load the model, get the input and output tensors, then pass the input value, and get the inference out of the model. So this is in brief the TinyML micro workflow. And yeah, by this time, you have created your TensorFlow Lite Micro project. Congratulations on that.
Playing from W10 JWBFPV2.
So as we discussed earlier, the TensorFlow Lite Micro model runs on bare metal, or it can also run on Linux, which is very small in size, right? And so now the deep learning model, right, we are able to run it on a microcontroller. That is a huge step forward, right? So we can create smart devices, we can create smart applications, and maybe you want to install a face recognition at your doorstep to see who is ringing your door, right? So, or you want to create a fingerprint based lock unlock for your house, or you want to detect a motion sensor inside the house, or you want to develop an application to find wild animal census, whether it is elephant, how much elephant populations are there, or you want to create a small sensor to count the number of cars, to count number of bikes, or count number of vehicles passing on a highway throughout the day, right? So such very small smart devices require a lot of machine learning algorithms to detect this object, to recognize speeches, to recognize the input stream, and all those applications, right? So this TensorFlow Lite Micro enables us to create those applications. And definitely, in your college projects, you can use this TensorFlow Lite Micro to enable your automations based projects, or to any commercial mass production applications, those kind of stuffs you can develop in using this TensorFlow Lite Micro projects. So there are some details or some caution I need to talk. As we discussed earlier, TensorFlow Lite Micro initially released in 2018, and there is a lot of community support, and it is growing every 6 months, and there are a lot of conferences happening around the world. And but the maturity of TensorFlow Lite Micro is still evolving, right? So still evolving, and this page shows the current set of operations available on TensorFlow Lite Micro. So that means suppose you are doing a speech recognitions or a text classification. So right now there is no support for recurrent neural network. Whether it is LSTM or GRU, there is no support right now in TensorFlow Lite Micro. There are the TensorFlow Lite Micro also not supporting the hybrid models. Hybrid model in the sense you can have multiple different blocks, like you can have a dense, you can have a convolutional network, you can have a recurrent network, all in your solution architecture. But the TensorFlow Lite Micro right now it is not supporting, but the community is very active, and we should be watching the TensorFlow Lite org Google site to get more information from time to time. But using the supported, as you see, there are many functions are already supported. The convolution, the image related applications are kind of supported using the convolution network, convolution function here. A lot of optimization functions also supported, activation functions supported, loss functions are supported. So using these available functions, we can write, we can develop many applications itself. So we already talked about many examples of applications like speech recognitions, or animal sensors, or counting vehicles, or creating authentication, or friend or image recognitions, or fingerprint scanning. So many ideas are possible using the current set of APIs, but still the support for recurrent and hybrid models are still evolving. Now, the TensorFlow Lite for microcontrollers. So this is a web page of Lite TensorFlow TF Lite microcontroller, and this page, if you visit, you already see support for a lot of hardwares and the example applications on these hardware. So as we discussed earlier, this open source community always encourages to don't reinvent the things again and again. So basically we take the pre-trained models, we do transfer learning, we take the existing code, we modify for our purpose, then we attribute the credits to the original authors also, right? So there are a lot of examples. These are some of the boards which already supported by the TensorFlow Lite microcontrollers. You can read the list here. The more information also available in the URL which I have provided here. And so this TensorFlow Lite Micro, I think this I already touched a little bit. So basically, usually the TensorFlow Lite Micro, or the small form factor, right? It is kind of a co-processor in many applications, like if you have an Alexa, or if you have a Google Home, right? It has a very small micro which detect for this command stream, audio stream, and then it hand over the processing to the main processor. So if you visit the TensorFlow web page, so there are a lot of descriptions about how to do these things. How do you delegate the task to a GPU? How do you delegate to a CPU? So there are a lot of examples also given in that page. But in this slide, what I want to convey is the facilities are available, right? The options are available for this delegation purpose. From this micro to TensorFlow Lite Micro to TensorFlow compute heavy processing units. Okay. So now I want to give few references. How are we going with time? Yeah. So the main reference here is the TensorFlowLite.org/Lite. So most of this content sessions, this session contents are drawn from this single URL, single source. If you see the guide here, there are examples here. There are the models here, the trained models here. So the advantage of going with TensorFlow Lite is there are examples, and then there are, if you I'm not sure if you are aware of the collab.research.com, right? So you can run the TensorFlow Lite. TensorFlow gives us a lot of notebook examples to directly run on their cloud platform. It is called Collab platforms. They have notebooks published there. We can run all these models without installing anything on our desktops or laptops, and it helps us to understand how this workflow is, and what are the different steps involved, and how we can improve this model. So we can do everything using the Collab environment itself. And the second source is, there is a TinyML Foundation. This foundation conducts a lot of talks throughout the year. The last one is just concluded in Asia, I think in Singapore or Hong Kong. There are, if you go to the YouTube for this TinyML foundation, you can find all the speeches from different industries and the practices, right? How they are making use of this TinyML framework using TensorFlow and different other framework also to develop an intelligent edge IoT devices. And next one is Pete, a book by Pete Warden. Pete Warden is the lead, technical lead at the Google, who is actively supporting this TinyML TensorFlow Lite libraries. So this book is from Pete Warden and Daniel. So so you can this is one of, I think there are very few books available, and this book is directly coming from Pete Warden, who is the lead of TensorFlow Lite from Google. So this is the one of the best resources available today. Yes, this book, if you see here, this TensorFlow Lite Micro is still evolving. A lot of changes are happening, and we are talking about like models within KB and a few hundreds of KB, few tens of KBs. Yeah, so and we already saw how this conversion, like the converting to hex format, then copying it back into our workspace. So it's still evolving. So maybe these steps will get fine-tuned in future, right? So but still there is a book available with available options. So the other one, there is one more resources which have seen. So there is an EDX course also available on TensorFlow Lite Micro, which basically covers most of the things which we have seen in today's sessions. Basically, how do we gather data, how do we train and deploy the tiny machine learning models, how to optimize the machine learning models used for tiny environment. We have seen that TensorFlow converter APIs, right? And how do we design your tiny machine learning applications, how do we collect data from the sensors, and then how do we inference, and basically the interpreter part of it, right? How do we invoke the model on an embedded device? So, and the last one is the various microcontroller support for available for TensorFlow Micro. So, but one point here is this course is also by Pete Warden and Lawrence Moran. So these are the people who created TensorFlow Lite, and yeah, so the EDX also provides an audit options where you can go and read and about TensorFlow Lite Micro. I'm not sure whether you have observed it. So for when we talk about this book, right, this book also has a YouTube playlist. Pete Warden is very friendly in that. So if he also released a YouTube playlist, which explains how to make use of TensorFlow Lite Micro for Arduino board. And so there is a playlist available. Go to YouTube and then yeah, you search the playlist by Pete Warden, and you can find the corresponding playlist associated for this book. So this is one of the good resources we can make use of it. And I think that's all I have. If I'm not sure how I did with the timings, hopefully it is okay. So if there are questions, if you have time now, we can ask questions, or you can also connect me in my LinkedIn page or email address. Anusha, over to you. If there are any questions, please let me know.
Right.
Yeah, Anusha, over to you.
So guys, any questions, please to post it in the comment box. So there is a question for you.
So it basically the community support. Am I audible now, right? So it's basically the community support, and so when we talk about PyTorch versus TensorFlow, so the TensorFlow has multiple levels of APIs. So TensorFlow, the bare TensorFlow, you write in the TensorFlow language, and then you use the Keras APIs, right? And then within the Keras APIs also you have sequential APIs as well as functional APIs. So these are different languages, so it basically depends on choices of people. So most of the functions are available in both framework, PyTorch, as well as in TensorFlow, but it's purely a choice of developers and the existing infrastructure the company is already working on.
More questions? Okay. So thank you, sir, for your influential knowledge. It was indeed a great opportunity to have you with us today. I request Ipshita for a vote of thanks.
Thank you.
Over to you, Ipshita. So there's one question which is posted. So can you please check?
Yeah, this question depends on the distribution. Yes, if it is Ubuntu, yes, on latest CUDA driver we have to install separately, but there are some distributions comes along with the CUDA library supported. But here here I want to see most of you are working in academics, right? So I would recommend to use the Google Colab cloud environment, where if you go to edit the notebook preference page, where you can select whether you want to associate this notebook to a GPU or a TPU, and Google provides a fair usage of their GPU and CPU, GPU and TPU resources for training the machine learning models. But if you are setting up for your own enterprise, or where you don't want to host your data on a cloud, then yes, definitely you can go with GPU. And we can, if you are using an NVIDIA GPU, we can, yeah, sometimes we have to download the NVIDIA GPU drivers from CUDA libraries from NVIDIA's GPU page and install. Yes. And if you do LS GPU, or now you can see whether there is a CUDA API available to see if your libraries are detected, your GPUs are detected by the libraries. And once you see that, then you are good to develop your deep learning based models to train on that GPU. But usually GPUs are very costly. So for academic purpose, I recommend to use Google's Google Colab, and where you can select your GPU in the notebook preference page, and then run your inference or training there.
Unmuted, correct. Audio unmute. Audio.
No, sir.
Are there any
Good
more
morning,
questions?
everybody.
So are we done? Ashok sir?
Yes. If there are more questions, I can answer. Otherwise, we can go to the next one.
So guys, are we done? Or do you have any questions yet? So Ipshita, you can go ahead.
Okay, thank you. Good morning, everyone. Am I audible?
Yes.
I, Ipshita Bhattacharjee, student of EPCET, feels honored to take the privilege of proposing vote of thanks on this occasion. I would like to thank our Honorable Chairperson, Srimati Ramadevi Ma'am, and our Honorable CEO, Shri Pramod Gaura and Shri Rajiv Gaura, for their wholehearted support. My heartiest thanks goes to our Honorable Speaker, Chief Guest, Mr. Ashok Narayan Potti, on behalf of East Point IEEE Student Chapter, for sparing his valuable resources and time and sharing his insight on machine learning, embedded, IoT, and micro devices. Thank you, sir. I would also like to thank our principal, Dr. S. Prakash, who always have been the backbone for organizing such kind of events like IKEA. Also, my sincere thanks goes to our HOD, Dr. G.S. Yogesh, who always motivates and encourages us to take such activities. Thank you, sir, for your kind support. My sincere thanks goes to the HODs of all the department and respected faculty members. I would also like to thank the IEEE Bangalore Section Chief, Mr. Punit Mishra and his team. Next vote of thanks goes to IEEE coordinators Dr. Vedavati ma'am and Dr. Rajesh sir for their kind support. To be mentioned, a vote of thanks goes to the student coordinator Saurav Manna and his teams. Thanks Anusha for your welcome speech. Last but not the least, my sincere thanks goes to all the participants for participating actively from various batches of India. Thanks once again to one and all. So there will be a validatory function at 4 p.m., but the winners of the function will be announced. Hope to see the mass again. Thank you.
Thank you, Akshita. Now it's time to introduce the events for the day. First one is Kaagad, which is a paper presentation, poster presentation, Insight, which is a mini project, and Kalasiri, the photography. Winning doesn't always mean being first. Winning means you're doing better than you have ever done before. So I wish best of luck to all the participants of various events. I now request the respective coordinators to take over and direct the participants for the day. So dear participants, please do follow up with your WhatsApp groups and link to the Google links sent on your respective WhatsApp groups. Thank you all. Thank you once again for joining us and gracing the occasion.
Thank you, sir, for your kind presence. Ashok, sir.
Thanks, Yogesh, sir.
Yeah. We'll log off. Thank you, everyone.